Hey everyone, and welcome. Artificial intelligence, it feels like it's everywhere, right? It's changing our world at a mind-bending pace. But what is it really? I mean, beyond all the buzzwords and the hype, how does this stuff actually work? Well, today, we're going to cut through all that noise and give you a really clear, straightforward way to understand the technology that is, no joke, defining our future.
All right, so here's the game plan. We're going to start with the big philosophical debate that really kicked this whole thing off. Then, we'll peel back the layers on all the key terms you hear thrown around. From there, we'll jump right into the generative revolution that's happening as we speak, look at the nuts and bolts behind it, and then wrap up with maybe the most important part. How do we build all this responsibly?
Okay, so to really get a handle on AI, you have to go back to the beginning. For decades, there have been these two competing ideas, these two philosophies about the right way to build a thinking machine. And this isn't just some academic debate. It's the core intellectual battle that has shaped the entire field. And this table just lays out that conflict perfectly. On one side, you've got symbolic AI. People in the field call it GoFi, for good old-fashioned AI. The idea here was to build intelligence using explicit, logical rules that a human can read and understand. On the other side, you have connectionist AI, which does the complete opposite. It doesn't care about rules, it just wants data. It learns statistical patterns from millions of examples. It's incredibly powerful that you can see that big downside. It's often a black box. We don't always know why it made the decision it did.
For a long time, symbolic AI was king. The goal was basically to map out human logic, to write down the rules of thought for things like playing chess or solving a math problem, but it hit a wall. It couldn't handle tasks that we humans find totally effortless, like, say, recognizing a friend's face in a photo. You just can't write down simple rules for something like that. And that's exactly where the other approach eventually took over.
Now let's clear up something that trips a lot of people up: the relationship between AI, machine learning, and deep learning. You hear these terms used all the time, sometimes as if they're the same thing. They're not. They're actually distinct layers of technology, and understanding how they fit together is key.
Honestly, the best way to think about it is like an onion. Artificial intelligence, or AI, is the big outer skin of the onion. It's the whole field, the big picture dream of creating any kind of technology that can mimic some form of human intelligence.
So yeah, just remember, AI isn't one single thing. It's the grand, overarching mission of making machines smart, whether that's through logic, or learning from data, or any other method we might come up with down the road.
Okay, now we peel back a layer of the onion, and we find machine learning. This is a specific way of doing AI. So instead of a human programmer sitting down and writing thousands of rules for the machine, we just give it a ton of data and let it learn the rules for itself by finding all the hidden patterns.
And peeling back one final layer, right at the core of the onion, you get to deep learning. This is a supercharged, incredibly powerful type of machine learning that uses complex structures called artificial neural networks, which are kind of inspired by how our own brains are wired. So if you show it a picture of a cat, the first layer of the network might learn to see simple things, like edges. The next layer combines those edges into shapes, like ears and whiskers. And the final layer puts it all together to say, hey, that's a cat. That multi-layer process, that's the depth in deep learning.
And this incredible deep learning power, well, it leads us directly to the technology that has caused this absolute explosion in AI we're seeing right now: generative AI.
See, most older AI was used to classify or predict things, telling you if an email is spam or if a picture is of a cat or a dog. But generative AI, it can actually create something totally new. It learns the underlying patterns in text or images so deeply that it can then produce brand new, original content that follows those same patterns.
And you have absolutely seen this stuff in action. It's the magic behind chatbots that can write an entire essay for you, image models that can create breathtaking art from just a few words, and now even video models that can generate whole movie clips from a simple description. It's wild.
The engine that's driving most of these amazing text tools are what we call large language models, or LLMs. And when we say large, we mean it. These are enormous deep learning models that have been trained on a massive portion of all the text on the internet, all the books. Basically, they've learned the patterns of human language at an unbelievable scale. So what made this huge leap possible? It was a breakthrough called the transformer architecture. And its secret sauce is something called an attention mechanism. Think of it like this. When you read a sentence, your brain automatically pays more attention to the important words to understand the meaning, right? The attention mechanism lets the AI do the same thing. It can look at a whole chunk of text and figure out which words are most important for understanding the context, which was a massive problem for older models. Okay, so we have the generative engine. Now let's quickly look at a few other key ideas that give today's AI all of its power and flexibility. First up is reinforcement learning. This is how we teach an AI to get really good at a game or a test. It's basically just trial and error, but on a superhuman scale. The AI tries something, and if it's a good move, we give it a reward. If it's a bad move, it gets penalized. Over millions and millions of tries, it just learns the perfect strategy, way faster than any human ever could.
Now, one of the biggest problems with LLMs is that sometimes they just make stuff up. It's a real issue, and the polite term for it is hallucinating. This is where a technique called retrieval augmented generation, or RAG, comes in. Think of it as giving the AI a library card and an encyclopedia. Before it answers your question, it can go look up the facts from a trusted source. This makes its answers way more accurate and reliable.
And all of this is leading us to what many people think is the next massive leap: AI agents. These are systems that don't just give you an answer, they can actually take action in the world. You could give it a complex goal like, hey, plan me a weekend trip to Paris, and it could break that down into steps, go online to browse flights, book a hotel, and build you a full itinerary all by itself.
So, with all of this incredible, almost unbelievable power, we have to stop and ask the really big question. How do we control it? How do we make sure it's used for good? And this isn't just a technical problem anymore, it's one of the most important conversations we need to have as a society.
And that brings us to the field of AI alignment. The goal here sounds pretty simple, but it is incredibly difficult. It's about making sure that as these AI systems get more and more powerful, their goals stay aligned with our goals and our values. We're trying to build systems that aren't just smart, but are also fundamentally truthful, helpful, and harmless.
Remember that black box problem we talked about? Well, that's a huge issue. We know these models work, but we often have no idea why they make the decisions they do. Explainable AI, or XAI, is the entire field dedicated to cracking open that black box. And this is absolutely critical if we're going to trust these systems in high-stakes areas like medicine or finance, where you have to know the reasoning behind a decision. And this slide shows how people are actually trying to do this in practice. You can see it's not about just training a model once and hoping for the best. It's a continuous loop. You train the model, then you test it like crazy to see if it's safe and trustworthy. If it fails, you don't release it. You go back, you fix it or retrain it, and you test it all over again. The idea is to build safety and trustworthiness in from the very beginning. Which really leaves us with what might be the single most important question of our generation. As this technology becomes exponentially more powerful, how do we make sure that what we're building isn't just intelligent, but that it's also wise? How do we make sure it's aligned with the best of our human values? That's a challenge that goes way beyond code. It's a challenge that asks us what kind of future we truly want to create.